So today, mainly today, we will actually be on our PG admin, and I've actually set some questions like tasks for us to do to actually continue with to continue from where we started. We had to just do one or some tasks to answer some questions. These are the questions here. So we actually solve that by querying these are database that we created last. So and part of these tasks we have aggregate function, which I will show you how we do aggregate functions. Aggregate functions like sum, max, mean, counts, and so on. So and also we also do joins. So and we have different kind of joints. We have inner joints, we have left joints, we have right joints, and we have outer joints. So on this question here, this is how to comment on SQL, or we can also do dash dash. So there are two different ways. This is just like a comment, like this is not a S query. So you open it here and you close it here. So these are the questions here. So we will be treating those questions one after the other. So to be able to understand. So please just try to download, please, because the best thing here is as I'm doing this, just follow, please. This will be very important. It's not by you just watching or just the theoretical aspect, please. Just please, the practical aspect also is very, very important. So it won't be new to us. One of the reasons why we are actually doing things on case study, because normally it's something I can just quickly explain. No, but I have to demonstrate it for you how it's done. And on the platform of actually, even if you want to talk about, because most interviews these days is all about what you know. So it will be very much easier for you to explain something that you did yourself, as maybe a project. They will always ask you, tell us about a project you've actually done. So you can always pick this, that, oh, this is so complain. You talk about your business problem, and you follow the STAR methodology, how to answer the interview question. You talk about the situation, the task, the action you have to take, and the result that it gives you. So if you are talking about projects you've not done, it won't be sweet like you talking about what you've actually done, because they will actually have subsequent questions. So please, let's just follow what we've done in class, please. So let's start from the first question here. Search customers by email domain. Because we added um something about this. We added this to our stuff, yes, the last class. So if you want to search customer by email domain, so let me start a question by, so to comment, this is another way to comment in SQL. So and okay, the question is yes, copy and paste. So we select. So from customers, it says search customers. So that'll be from customers table. Where, so these were the where email. Okay. So let's say, so we use this to actually search this command I like. So and let's say the so the domain is okay, let's use this. So it ends with this percentage means ends with, so at gmail.com. So we use this to search. So that. So that's it. You can see the research through the Gmail. So these are the customers and their Gmail. So let's go to the second question of our task for today. So it says select orders with a specific date range. So we'll actually search for a specific date range. So let's comment. So select order from a specific state range. So you select star. Inserted data into 4 tables: class table, orders table, order items table, and products table. Remember, these are tables. Remember. So now what we are doing today is these are I just after okay, it's just like okay, after successfully creating your tables, you are required to carry out the following tasks. So I just create these tasks. So these are the tasks we are to do. So
Thank you.
we are to view. Okay, let's view first 100 rows. So can you see? These are customers table. It has columns are customer ID, customer name, the name and email. So the second table is this these are orders table. So it has order item ID, order ID, product ID, and quantity. And these are orders table. You can see that. So and we have our products table here. So can you see that? So our product table, we have name, price, and we have category. We did something on like foreign key, primary key, if you remember. So we actually use some of that today. Well, where's the command? Uh, wow. Okay. Okay, sorry. Yeah, don't mind me. So the question is select orders within a specific date range. We have customers table, order items table, orders table, and products table. And the question says select orders within a specific date range. So that's from orders table. That's from orders. So where orders dates in our orders table, we have orders dates. That's orders okay, order underscore date. Sorry. Other states that will be between. So a specific okay, that will be between. I will explain the commands between. Let's say okay. Think so. What we want to search is what orders between 2022. So that will be 31. So between within a specific date range. So date range we are picking is okay. You want to search for orders in 2021. So that's between 01 2021, January 1st, 2021, and 31st of December 2021. 2022, sorry. So that's that. So these are the orders for 2022. So can you see that? So even this, the find product price within a range is still the same method. So as this, so it's still the same thing. The way we do this, that's why we use the between and hand. So let's go to find the total sum of per category. So here we are using aggregate function. So I'll show you how we do this. So this is aggregate function. Here we'll use sum because it says total sales per category. So here mainly we are using okay total sum per category. So let's search. I think category is in our products table. Okay, these are our products table. Okay, let's see what's in our products table. So let's see what's in our product table first. So we know the columns we have to select. So it won't be confusing. The star from products. So let's see our products table here. Okay. So our products table here has product ID, name, price, and category. So the command says find the total sales per category. So definitely we are using the products table. So I did this just for us to view what's in our products table. So here it said select, okay, find the total sales per category. So select, anybody have idea of what we select? We select category, says we should search back category. Says category, comma. So after okay, after category, we have to search sum. This is where the sum functions enter. Search total sales per category. So here we know sales will be that will be price. Okay, per category, that's price. So here we are using two tables. We need to know total sales. Total sales definitely will be price times quantity. So because total sales. So to know total sales, we know the price of what of the products we are buying times the quantity. And here the quantity is not here. So we are doing this. We are not okay. Here we can use joints to actually solve this problem. But no, I don't want us to use joints, yes, because we'll soon move to joints. There are some other questions we have to use joint, but I just want to show you how this can be done using aggregate functions. So yeah, so we know that will be price. That will be sum of price times um quantity. Then quantity is in the others item. So we'll actually pick that from the other items table times quantity. And yeah, there's something called alias in SQL. So instead of writing this like, oh, sum of price times quantity always in our query, we just alias it. So it will make it short. Don't worry. And there's I will also alias our tables too sometimes. So we will actually mention the whole table in our query. So alias it as total sales. Okay, total price or total sales, anyone. So we alias it as total sales instead of writing sum of this. So sum of price times quantity as we alias it as total sales. So please ask question if it's confusing. Oh. So from two tables here. So we have quantity from others items table. So let me query. Let's see what's in our other items table. Okay, let me make this other items instead. So these are products table. We already see the columns here. So let's make this other items. So let's see what's in our other items table. So these are other items. So let's query. So you can see quantity is there. So these actually from two tables. Other item, other items, and product table. Yeah. So the price is from the product table. And category is also from product table. So from this product table, so where other item dot our other items table, this is it. It has so yeah, you know, this where it is we are now using, product ID, other item dot product. So yeah, we are finding a connection between these two tables, other items table and products table. Where is the connection? So okay, let's check. This is order item ID, product ID, and quantity. And let's search for our product table too. So please tell me just take note of the columns here, please. This is the products table. Columns. We have product ID, name, price, and category. Can you see that? Product ID, name, price, and category. So let's see what's in our other items table now. This is other item ID and product ID. Okay, let's search our product ID again. So let's be sure. Products. So we have other item ID and product ID. Okay. So do product has other item ID? Let's search. No, it's just product ID. Okay, so that's the product ID. That's the connection. And from what we did last class, the product ID here is a primary key, PK, primary key in products table. And it's a foreign key in other items table. So we'll now do that's the connection. So we will use the connection products dot products dot that will be dot products. product underscore ID, because that's the connection. Can you see that? Is equal to, so product ID also, the connection. That will be product table also dot product underscore ID. So can you see that? That is the connection. These are product table. This product ID. Just take note of that. So let's search our others item, other items table. Okay. So you can see, just take note. This is the product ID here. So let's take note of that. So you can see product ID. It's a foreign key here. Don't look at what is in here. You understand? Don't look at what's inside the column. The connection here is the column. Okay, what column? This is a primary key here, other item ID. But this product ID is a primary key in the products table. So that is the connection between both table. Yeah. So now other item table dot product ID, because this is the connection, and the product table dot product ID, because it's a primary key on the product table. It's a foreign key on the other item table. So we are using that column to connect both tables. You understand? That's what we did. So the connection between both table is the product ID. You understand? So yeah, we'll now use group by, because it's the question is find the total sales per category. Group by category. That's it. Category. So very straightforward. My category spelling is wrong. So we might add this, we might not. It depends. So let's see. Will this work? Yeah, that's it. Group by category. So this is the category, total sales. So now our SQL here, this command already multiplied price and quantity for us. You understand? Because price, total sales is okay, the price of what you bought times the quantity. What that means is, okay, maybe for example, the toy here, the price of the toy is maybe £700, for example, and you bought three. You understand? So the total sales will be what? £700 times three. That's the amount of what you bought. You understand? So that's the total sales. You understand? So these already do that multiplication for us, from because we actually command it. Okay, do the multiplication of the total sales for us. So what we just did here, instead of making it okay, maybe you should just give us okay price times quantity here as a column. No, we alias it as okay, make it as total sales. So that's total sales for us. Can you see? So these are the total sales of electronics, total sales of toys. You understand? So this is each categories, total sales of what's of all electronics, total sales of all toys, because we already said sum. So it should sum all totals, all price times quantity. You understand? So this is the summation, and this is each categories of what we have. Okay, we sell electronics, we sell toys, we sell home and kitchen, we sell books and fashion. So these are the categories available. So we group it by categories. It's just like interpreting English with your queries. Okay, this is the next question. Find the highest selling product. So we want to search for, okay, which product is the highest selling? Like, okay, find the highest selling product. So even these two, we are joining two tables together. Okay, so we select order item. Okay, we select, okay, no, products. Okay. I'll explain the table for you. So it says select highest selling product. So we need the product name. I will explain why I use this, just to specify which tables we are picking, we are selecting from. The quantity in order item. So let's alias this as total quantity. So this, what I did here is actually I actually pick, like, okay, I select product ID from this from other items. I select product ID. You should give me product ID from other items. That's why I did dot product ID. I might do product ID actually, but product ID also from the products table. You understand? So specifically I need the one from other items because I need quantity from other items. So, and I select product name from products, because name is not in other items, and we have names in name in products table. So I select product name in products table, and I want summation of quantity. You understand? Summation of quantity. It says find the highest selling product. So I want the summation of quantity also. So this summation of quantity, I don't want it as, okay, summation of
What
quantity
is
in
it?
my columns. So I alias it as total quantity. So that's why I did that.
Not
So
yet.
from that's other item and products. Other items dot, that'll be products underscore ID is equal to products dot products underscore ID. And also, okay, I think that's that. So now we need group by So we'll group it by, because it says find the highest selling products. Group it by, here we group by categories here. Okay, group by. So we are grouping it by this, what we select. Order item dot product ID and the name. So we are grouping it by, so it will by this. Here we group it by categories. That's why it gives us in categories. So here we want it to group it by the product ID. It should give us the product ID and product's name. Because we want the product's name also. Like, okay, apart from the product ID, give us the product's name too. So that's why we are grouping it by. It's just like filtering the columns. Yeah. So, and here we have we order it by. So order by, because this is what we actually wanted. This is also a filtering command query. So we order it by, these are total quantity. And our total quantity is the summation of other item. So so that's order by. And we said the highest selling product. So to find the highest selling product, to how will I put it? To aggregate, like to actually, okay, for example, if we say, okay, top two, if we need something like top two, top three, or highest, we use a command called limit, a query called limit. So we want to limit it to just, we want the highest, that will be one. Assuming we want top two now, we'll make the limit two. So we are just telling the query that, okay, we want the highest selling, that's top one. So that will be one. If it is top two now, it will be two. So if it's three, top three, it will be three. So our limit is just one because we want the highest selling products. So and we order it already with the products group it by the product ID and product name. So this is the results. Wow. Oh, there is a, okay. Which table is it missing from? Other item. Okay. Yeah. Yeah. This is the mistake here. You can see it gives me where the mistakes actually comes from. I didn't put S. So let's query this again. Wow. Insert into product. What's the problem? Why is this not working? So can you see? So product 406 is our highest selling product. Can you see that? So it gives us the product ID. So assuming, so reason why we group it by this and we order it with this, it should be in order of this. Like, okay, which one is the highest selling product? So this is one. The quantity. Okay, we want, okay, highest selling, but the quantity of what we have of what we sold. So this is the highest one because we order it by this. This is ordered by this, but we selected group by, so it should be group by. We want the product ID and the name of the product. So that's why it brings this is the product ID 406 and the product's name that will be products 406. So assuming we say two now, it will give us a top two. You see, it gives us top two. You understand? That's the work of the limits. It limits this to top two. The highest, we want just one. That's why we put one. Okay, find the categories with more than 10 sales. I just want us to follow. So these here too we will use an aggregate function called count here. We are not using sum. It said find the categories with more than 10 sales. So we need that's count. Here, find the highest selling product. So highest selling, we use sum here. So it's different questions. So you need to understand the questions before you actually continue with your query. So yeah, we select category because we are finding the categories with more than 10 sales. Select category. So yeah, don't worry. Yeah, I will do something here. I will alias there will be like an alias to our tables. So in case instead of just saying our order item table, products table, I will actually alias it. So I will use count. There are different methods actually. This question now. You can actually query it in any with another method. You understand? So it's just for you to understand and know the command. Okay, when will I use my select? When will I use from? Okay, where will I use filter? Filter is filtering. Okay, when will I use my group by? When will I use order by? You understand? And when will I use limit? It's just okay, when will I? So you can actually query this in another way. It might not be like this. So it's just for you to understand what you're actually doing. There is no one specific way, it's just like Python too. There's no one specific way to actually program. You just choose the one that actually suits you. So yeah, you use count because we are counting the ones that has more than 10 sales. So count. So you should count order ID. So as instead of saying putting these as counts order, so let's just alias this as order counts. Order underscore counts. So this will actually be from. So here it says find the categories with more than 10 sales. So we'll actually need from the products table. So let's query. Okay, let's see product table. Need from the product table. We need from the product item, and we actually need from other item table, and we need from other table. So we need from those tables because we want. Okay, this is our products table here. Category here from the products table. So it says sales. So we need category, we need product ID from here, from others too, because it says just interpretation of the question. Well, okay, it's others. So here too, we need let's say okay, yeah, we need the order dates. So that will be from let's say order. So instead of let's say orders as OD, that's OD, we just alias instead of here we did order item dot product ID. So assuming we alias this as OS or something, for example, that will be OS dot product. Instead of writing this order item, instead of we just alias, it just means making it short as OD and order item. We need order item as okay, let's order item. Okay, that's O high. Let's make this O high and product as PD. Might be capital, it might be small. So anyone where, so this is filtering, where this is where the connection, that's where from other OD, that's other table dots, that will be other ID. Yeah, that's other table dots. That will be other ID is equal to, and that will be other item. I don't think we don't need the product table here. Yeah, other item, that OI dots, other underscore. Okay, we need that too. Yeah, the item. So yeah, OI. This is other this other okay, these others OD and this other item. So we need the product too because we need product name. So we need category of the product. So to give us okay, we need the product ID. So yeah. So and that will be, and let's paste this. Oh hi. That's other item dot product ID. The connection, we know other item and product ID, they have product ID in common. Product ID underscore ID. This is a join. So this is the connection, and product ID, that will be PD because our product table PD. We alias it as PD already, so dot product ID. So product ID. So that's where, and we are grouping it by, we are grouping it by that's category. So yeah, because we need category from product table. Yeah, I think category is in product table. Let's search that. Yeah, category should be in product table. Let's see. That's PD. That's our product table dot category. Category. So we are grouping it by. So we are using Arvin. Yeah, I'll tell you why we are using Arvin. So Arvin. Yeah, that is a filtering. This is where, okay, find the categories with more than 10 sales. So count. This is where it works. Now we having counts. That'll be okay. Greater than. So greater than, more than 10 sales. So having count. So counts of this other ID. Count of this other ID that has more than 10 sales. So I will actually explain the query. So let's see if it works. Oh, think there's a mistake here. That will be count. Okay. No. So that will be OD. Let's use OD dots. I'll explain that. Yeah. Yeah. That's OD. That's others table. The other ID from others table. Yeah. So I think this should work. Yeah. So that works. So here we have to look for categories that has more than 10 sales. Any category that has more than 10 sales. So what we did is we select category. So and we select count. That will be numbers. How many? It should count using this order ID. And order ID is in order stable. So we use instead of measuring just order, if we write order dots orders dots order underscore ID, it will actually give us the same. But we are already alias this our orders table as OD. So that's why I use OD dots orders item dot order ID. So count of this as orders count. So that's why it brings order counts here. So we already alias this. That's why it brings this. So from which table? From our orders table OD, and we need as OD order items table as OHI and products ID as PD because we need that. So here where OD dot order ID. This is a connection between the order ID and the order items table. We order ID here, and the connection between product table is the product and the product table and the order item table is the product ID. That's why we use and. So you should group it by categories here. These are the categories of what we are selling. Having so this having is like another filtering query that okay, we want categories that are having sales that like, sells more than or that has okay with more than 10 sales categories with more than 10 sales, so having count of order ID that is having more than 10 sales that's greater than 10. So instead of writing orders table here, we already alias this as OD. These other items, so instead of writing this, it's just like alias is just like okay, you actually do something now. Okay, maybe you write a query instead of writing the long query like this. Now, this counts OD dots. Instead of bringing this here, we just alias this as order underscore count. So that's why it brings alias on order underscore. Alias is just like making something short, something long. We want to make it short. So that's it. So here it says find the average product price per category ordered by price. So here we select what category order per price. So do select category, select category. So it said find the average product price. So average price. So we use aggregate function AVG. You know, we use the aggregate function we use here is count. The previous question we use sum. We use sum. So these are aggregate functions. So we use average AVG. So average of price. So average of price as average price. So instead of giving this AVG price, so we just give us average. Okay, price. So instead of giving us this, just give us average price. From that should be our product table. Yeah, let's query our product table. We have category and price here. You understand? So all we need here is just our product table. That's from just find the average product price per category ordered by price. So we need price and we need category. So from product, so we group it by, because it says find the average price per category, per per category. So this category order by category and group by category average price. So now there's another thing I want to introduce here. This will actually run, but I want the results to be from highest to lowest. So I use this descending because naturally it gives results in ascending order. You know, if you do not put this, it will give us results in ascending order. But if we put this, it will give us from highest to lowest. We will actually try both. Okay, I won't add this now. Let me run the query and let's see the results. So, mm, okay, there's a mistake. Okay, average here. See, it will actually tell you where you actually make your mistake. So that's it. You can see it's giving us from lowest to highest. You understand? You can see average price. So naturally to give us in ascending order. So, but we want it from the highest to lowest. So that's why we use descending. So you can see from highest to lowest. So average price of fashion is the highest. So followed by electronics. Fashion is the highest. Electronics is the second. So this is descending. But naturally, without putting this, it will give us in ascending order. The main thing in programming and in maybe query language like SQL is just know what you want to do. You understand? If you know what you want to do, it is very easy for you to research. It's just like you don't know anything about Python now. So you are given maybe a project to do that. You just go to ChatGPT, for example. Just say, "Oh, ChatGPT, build a build a program for me to run blah 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 blah." Even ChatGPT will hallucinate. So it will just bring different. You won't even understand, but you already know what you want. For example, now we already do this. You can just put your query to ChatGPT. ChatGPT, please, how can I make the average price in two decimal places? That's how you use AI in whatever you are doing. It's not that okay, you just go to ChatGPT, you don't even know anything about SQL. You just say, ChatGPT, give me this. You won't even understand. It will actually hallucinate for you. You understand? But you have to know what you are doing. So anything you need subsequently from that, you might want to make changes. It's very much easier because of our time now. We can actually put this on ChatGPT and it will always give us the result. Okay, just add this query. So that's how to use because even ChatGPT will always hallucinate. But if you give ChatGPT a nice prompt, you already know what you are doing. Okay, ChatGPT from my project, I know my Python this is that. This you understand. Even ChatGPT will give you something precise. But you just put it on ChatGPT, it will hallucinate. It will even bring the best result for you. So that's it. So you can always make researches on things, even on your own. If you feel like okay, let me try this, let me try that. So get product and their orders. So that's the next one. Get the product and their orders. So here we need let's use joins here. It says get the product and their orders. Joins. So these take us to joins. So from this join, I will actually want to okay, let's quickly do this join. Let's explain joins to you using this Google search. So in joints, we have what we call inner joints, we have outer joints, we have inner joint, we have outer joints, we have left joints, we have right joint. Yeah, those are the four types of joints we have in SQL. We have inner joints, left joints, right join and outer joint. So what is inner joint? So probably inner joint actually gives us the outputs that, okay, let's say it gives us results that actually the relationship between both tables. It's just give us it's bring the result is just okay, the relation between two tables. So let me give you an example. This is an example of inner joints here. Let me expand this. Yeah. So this is inner joint. This is two different table, A and B. So this is A, the whole of A here, the whole of B. So inner joint is just the relationship. What is common? That's what inner joint. Please jot it down, please, for reference purpose, so you understand. Inner joint just gives us relationship. That's the relationship. A and B. This is the relationship here. What is common? So this middle. So from here, let's find a table. This actually explains it better. These are okay. This is two tables here. No, sorry. Let me use this. Yeah, this explains this better. Yeah, this is customer table here. This is orders table. You understand? So what we want here is what we want here is what is common between both tables. So this is customer table. We have customer ID and first name. This is orders table. We have order ID, amount, and customers. So yeah, what is like yeah, like the common thing here is we have customer ID is the okay, it's bringing okay, customers, customer ID and customers, yeah, the relationship here. Yeah. So we have customer ID, first name, and amount. Wait. No, no, sorry. Yeah, I want something that will explain this better. Sorry, let me just see. Let me bring pictures out. Just gives us the relationship in our joints. Yeah, what I want is oh yeah. Yeah. This is left table. This is right table. Let me use this. So what this will actually do is the relationship here is the ID. So it will match both tables. Like okay, dates. Yeah, okay. I'm finding there is one specific table that actually explained this better. Yeah. Sorry. Oh, why is this doing this? What I need is just the picture. Yeah. I don't need this. Yeah. So this explains better. Sorry. Oh, what am I doing? I want to bring this out. Yeah. So from this table we have oh oh yeah. From this table we have customers table here. We have others table here. So now you will see this is the relationship customer. So you have customer ID, the first name, and the amount here. So it gives us customer ID, first name, and amount. So you will see what the result it brings out here is the relationship. Like okay, every customers, every you see this customer ID here and customer, same thing. So now the result it brings out is just the ones that has okay, we have in the customer ID here, there's customer ID 3 year and there's 5 year. Here there's 3 year, there's 5 year. You understand? So it brings all the results, okay, all columns here that have this 3 and 5. You can see this 3 and 5 now is 500 and 800 amounts. So the first name the first name with customer ID 3 is David, and the first name with customer ID 5 is Betty. You can see David and Betty. You understand the relation? What is common? You understand? The output is the relationship between both. Okay, what is common between both tables? So it brings it out. Here too, customers here is 3 and 6 and 6 and 5 here. So 3 and 5 is the amount here is 300 and 800. So that's that. So that's inner join for us. So let's look for what's the next one? Let's say left join. Yeah. So this is left join. So it just brings everything like, okay, this is table A and B. Why is this doing this now? Yeah. This is table A and B. So what we want here is the left join. You can see it's just everything from the left, the relationship and all the table from the left. Do you understand? So all the table from the from the right without the relationship, it won't bring it. It will actually give us null. You understand? Okay, let's say this table A, this table B. We have ID and we have products. Here we have price. So here it will join all these columns together. ID, products, ID, price. You understand? It will join all, it will put all these columns here together. But we want everything from the left. You understand? So everything from the left here is, here we have chair. This product ID here, we have one. Yeah, okay, it has one. So it will actually give us this. But this one is two. Okay. Everything from the left, actually. So this one, product ID is one, two. We have here is table. Here, two. It gives us 120 because everything, you understand. So it gives us everything from the left. So we have three, with something that is common. Two is common here. So here, three. Three is not here. You can see from the table A, laptop. You can see laptop here. ID because it's not common because it's on the right table here. So it won't bring it for us. Null, null. You understand? It brings null, null because it's not on with this ID here. Three is not here. You understand? It's just like the way we explain primary key and foreign key. This is a primary key. This is a primary key here. There's something common between both tables. So this ID is what is common. You understand? And everything from this A table. You understand? So that's that. So everything from this table that is not common, it won't bring it out. It will give us null. So that's left join for us. So right join is the opposite. You understand? Is the reverse is the case. So right, for example, if it is right joins now that we want, right joins will give us everything. Assume okay, this three now we have four here. Okay, we have four here. We have three here. So right join here with this three, it will give us null. You understand? Because is you understand? It's just like reverse indicate. It's just like reverse of what is in table A. You understand? It gives us everything that is on this table with what is common between both table, but it will leave everything what is on table A that is not common. So it will leave this. So that's it. So let's look for outer join. Let me just find yeah. So these actually explain all. You can see left join everything from the left, right join everything from the right. You can see with what is common. Inner, what is common between both table. Outer join is also called full join. So everything on the table, just join both table for me. That's outer join, full join. So these are questions. It says get the products and their orders and their orders. So we need from the table. We are joining two tables here. The product and order. Yeah, we already see it. The question is straightforward. So order product. Okay, get the products and their orders. Okay, we need dates too. Product dot. PD means we already put this as product table. Like we already put this as products. We actually alias our product as PD. So that's why you select PD dot name, product dot name. You understand that? That's PD. That's our product table dot name, and OD is order table dot order dates underscore dates. Nah, because it says get the products and their products. So get the products and their orders. So it's like what is common between products and orders. So inner join. Actually, most times we use inner joint in most case. So inner join. So we are inner join. We want to join other items as high. So you see what we're joining here on. So instead of is equal to in what we have been using, so in joints, we'll just put on, okay, we are joining this from this table on okay, on high. So what are we joining on that table? OI dot product underscore ID, product ID, and okay, what's the in other items and okay, products or other items table and products table, that's underscore ID. Okay, is equal to PD dot product underscore no, it's product underscore ID. So inner join and we want to join orders and orders item and orders table too. So because we are joining columns that we actually need. So those are so it will actually give us all those columns. So yeah, inner join also. Yeah, inner join orders orders as OD. Yeah, because we've been using OD on. So we join inner join order item. Inner join this table as OI on product ID on this and what is common and product ID on products. So here will be OI order dates. So here we have order dates is common in that's order underscore that's OI orders item table dot order dates underscore under ID sorry order ID yeah order ID is common in the orders table and the other items table is equal to od dot order underscore id. You can see order ID. We know this order ID product the other items table has order ID and orders table also have order ID. Product ID we know orders items table have this and products ID also have this. Products table also have that. So that's in our join. So let's see. So that's it. That's joint for us. It gives us the name and it gives us other dates because that's what we pick here. Give us the name That's the um the name is in the products table, and give us order dates. So we want the order dates. So the order date is in, I think, order item also table. So from products table, so from this products table, so inner join from this product table, another table. So inner join. So we are doing two inner joins. So we inner join from product ID. That's the product item. The product ID is the okay. We need okay product item here. On product ID is a common column here. And also inner join as on orders too. We have order ID. So that's that. So let's move to the next question. So get the customers and their orders. So get the customers and their orders. The first one is get the products and their get the products and their orders. Yeah, get the customers and their orders. So yeah, we can use um we can use inner, and we can use left join. So right join, we don't really use right join in SQL. Most times it's always inner join and uh left join. So here it says get the customers and their orders. So this will be much more straightforward. So let's use left join here. We can use inner join also. Select customers. Let's say customer. Okay. From the customers table, name. We can alias, we might not alias. Depends on how you want to write your whatever your query. And orders table dot order ID. So we want everything from the left. Yeah, what we actually want, what I actually want to do here is I want everything from the customers table. But on the orders table, I just want the what is common between customer and customers table and orders table. But I want everything on the orders table to show. So that's what I actually want. So yeah, assuming if I do that here, it will give me, yeah, it gives us what is common only. What is common between the products table and the orders table. That's what inner joint gives us here. You understand? So yeah, if we use left join here, it will just give us everything on the products table. You understand? But what is common between both products and orders table? You understand? So that what it will bring for us. So it's different results. So yeah, we want everything from the customers table and every what is common between customer and orders table, but we don't want things on the orders table that are not common. So that's that. So that's what we're selecting from customers. Customers table. From customers table. And we just say left join orders on customers. So what is common is customer ID. Yeah. Okay. Customer ID. That'll be customers.customer dot underscore ID is equal to, I think orders also have customer ID. So this one will actually give us that result. So that's left join. Left join is too much straightforward. So you see. So what it actually bring for us is what this actually brings for us is we select name and order ID. So this actually gives us everything on the customer's table. But on the other table, it gives us what is common. So anything that is the remaining of the others table, it won't give us. It will be null. So assuming if we do outer join or full join now, it will give us everything. So let's just treat one more question. Okay, but this would be okay. Unique. Okay, let's treat these two questions. Yeah. So that's it on join. Unique customer. Okay, list all unique customer name and product name in one column. That's the question. So there is another query command we use in this command V because of unique. So that's it on joins. So here it says list all unique customer names and product name in one column. So this will actually give us one column. So what we'll select here is select name, customer name from customers. That's customer name and product name in one column. Yeah. You understand? So it says, yeah, from customers. So we use this command union because we want it in one column. Union two is just like join. It's just like outer. It's kind of related to full join also. List all unique customers name and products name in one column. So union, we select again name. I think product also has name from products table. That's that unique customer. So union because of that unique. So in one column. So that's it. That union makes it in one column and it's unique. So the name, the product name, customer name. So union. So like joining. Because it's unique, that's why we use union. So do you see that in one column? So let me treat the last question here. So we'll do what is called concatenation. Concat still is still like joining, like concatenation. So combine customers first and last name into a full name. So into a full name. So maybe you're having customer table, customer last name and first name. You want to join. So that's concatenation. So that's concatenation. So to concatenate, we say we select, okay, we are selecting name, select name. So this is the concatenation function here. Where is it? Yeah, sorry. This no, yeah. Two of this, that's concatenation function. So if you want to concatenate, so this concatenation function, So concatenation. So here we want to join and email because we don't have a full first name and last name here. So in our table, sorry. So let me twist the question as okay. Let me join email. I want to combine name and email together. Yeah, okay. I want to combine customer's name and customer's email because we have email colon. So as that's concatenation. These are to concat. You use this trait. What will I call it? Is it column or bracket? I don't even want to call this. Sorry. So we use this. Yeah, we put it here and we put this apostrophe and put this again. So this is the main concatenation function. These two. That's concat as this alias as so it should alias this for us as full name as full details. Okay, let's say full details or let's call details. So from customers table. So customers. So let's see. Let's see the magic if it will work. Yeah, you can see it gives us together. Assuming we're having first name, maybe in one table you have first name, in another table you have second name, last name. So it will concat it together, it will join it together. You can see that's this is how concatenation works. You can see it doesn't give us in columns. So you can see full details, customer name, customer one, joins with its email because there we don't have customer name, first name and last name. So this concatenate, it joins it together in one table. That's when we use concatenation. This one to union is in one table. You understand? So that's it. I think that brings us to the end of SQL.